So we're in your chemistry and we're on chapter 3. And this chapter is called Stoichiometry, Elements and Compounds. Well, what is stoichiometry? Well, we're going to find that out in a little bit. And later on, we're going to talk about Avogadro's number, moles and molar mass and number of moles. And that's going to be in the next section. So let's talk about, we're talking about Dalton's atomic theory. And we're going to be talking about elements and compounds. Well, we knew last chapter we talked about elements, and each element has a name. Let's go back to those names real quick here. I want to look at the names because you need to know these names, even for your test, at least some of them. So let's go back to that. I'm going to go back so you can see those. We're talking about different elements here. It's on this page here. Okay, you see all these elements here? Let's make it a little bit bigger here so you can see. There we go. These are all the elements here you need to know. The first up here talks about the elements of hydrogen, oxygen, nitrogen, fluorine, chlorine, bromide, and iodine. You need to know these, right? And you know that this table is in here, but these are how you pronounce. So when you see a H, you know that's hydrogen. You see a O, you know that's oxygen. Very important. Then we have these down here that are kind of rare. I should say more rare. And so if you have one of these, it's good to go back to this table. Just remember it's on page 19 in your book. And so here you have all, like you have aluminum, argon. The ones in bold are ones you need to know. Barium, bromide, carbon. Carbon's very important. You need to know that. Calcium, copper, and going all these helium, hydrogen, iodine. You know all these and the symbols for them. And we learned that last chapter. So that's important for this lesson too, because we're going to have formulas and we're going to put these elements together. So we have to know what the element is that we're putting together. There's some rare ones like, zirconium or something, but you basically knowing what zinc is, potassium, of course, we learned some of them don't look, potassium is a K, so it's not even, how about, and mercury is a Hg. So you need to know these, and at least go back to this table if you need to find these out. So then now let's go back to where we're at. I just wanted to put that there because on the questions, all the questions, they're going to ask you, and you need to know these certain elements. So let's go back to where we were. Okay, stoichiometry. Basically, we're looking at molecular formulas. What's a molecule? A molecule is where two elements, or two atoms, which are elements, are put together to make a molecule. And these are compounds. And so we have the abbreviations that we're going to use, of course, like H2O. If we take H2O, that means what? 2 of hydrogen and 1 oxygen, right? How about CO2 here? That means 1 carbon and 2 oxygen. That's basically what we're going to be talking about. So there are types of chemical formulas. We have the molecular compounds that are composed of molecules, which are groups of 2 or more that are linked together by chemical bonds to form distinct molecules, right? Distinct substances. So we also have ionic compounds, and these are going to be a little different because we can't always use the molecular formula for the ionic compound. So we're going to find that. But ions are composed of lots of ions. They're all electrical charge, and sometimes they're all hooked together in one big crystal. But they have a basic imperial formula for ions, right? And we're going to get into that in a little bit. And then, of course, we have molecular formulas. And so this is what you're familiar with. Like H2O would be that molecular formula, which tells how many of each type of atom are found in the actual molecule. And these molecular formulas can be used to represent any molecular compounds, which are composed of individual molecules. You can't really use them for ions, right? But you can use them for their molecular formula, okay? So let's go on to the next page. So here's a picture here. So Empirical formulas. Empirical formulas, you can use those, basically you use those for ions. But what is an empirical formula? Well, an empirical formula, basically we said, first of all, we said a molecular formula tells how many of each type of atom, right? So here's each type of atom. There's 6, this is 6 of carbons, 12 of hydrogen, and 6 of oxygen. Well, this is the actual molecule, and this is a molecule of sugar, of glucose, which is sugar. Well, if you broke this down into what the ratio is, the little ratio of it, you divide each one of these by 2, or actually divide each one of these by 6, because that would be how far we can go. We have CH2, because you divide 12 by 6, and O. So our empirical formula would be CH2O, and it would look like this. But as you can see here, this has to come together in a big molecule. So usually molecules, you don't want to use just empirical simple formulas, but that would be the empirical formula for it, right? So these are 3 different compounds here with the same empirical formula. So they have different structures. They're not even the same thing, but they have the same simple empirical formula. Like a compound of propane, or propane would be C3H6. Well, the empirical formula, if you divide this by 3, and you get down maybe the least common denominator there, and you get CH2, because you divide these by 3, and this would be the empirical formula. So this here is butene, and butene is C4H8. Well, you can divide these by basically by 4, right? Because 4 goes into 8, so then you have CH2. That would be the empirical formula. Basically, it's the simplest ratio. And so this here is cyclohexane. Now, all these are not the same substance, which is really weird. That's why you can't really use empirical formulas for molecular formulas. We're going to use them for electrons, for basically when we go on to ions. But here we have C6H12, and you divide those by 6, and you get CH2. That would be the simple empirical formula. So now, so you know what an empirical formula is basically shows only the simplest ratio of atoms in a compound. Where the molecules show, or a molecular formula shows all the molecules. Like, oh, we have 3 of these and 6 of these all put together, and that's what the molecule looks like. So that's a molecular. That's kind of what we're all familiar with, is molecular formulas. So, and just to know, the empirical formula is basically showing the very simple, and the simplest in molecules. You can have totally different types of molecules. Okay, so I hope I explained that right. So a formula unit, okay, as we see here, the simplest ratio, this empirical formula is basically used with ions, because ions they hook together by their electricity, by cations have a positive charge, and anions, as we know, have a negative charge. When they hook together in this empirical formula. They don't hook together in a regular molecule like this. So this is what we use usually for ion formulas. Okay? And they're most useful. Empirical formulas are most useful in extensive, big, huge ions, where you have like thousands of ions together. You have to have a very simple formula for thousands of them hooked together, right? So, okay, I hope you get that. Just think of what empirical formula, because we're going to be talking about that. You know, it used to be very, very strange in naming, because we're going to talk about now naming. And this is where we're going to focus on for the rest of this video here, is naming binary molecular compounds. That means binary means 2, how they come together. So now you can take molecular. We're talking about molecular, not ions, you know, and how they come together. Well, basic ancient alchemists a long time ago, they gave really confusing names to stuff. Like they call something the butter of antimony. What in the world is the butter of antimony? Or sal alemanic, or spiritus salis, for spirit of salt. Now, how would you know those things? Well, they had to have some way of naming these different molecules and stuff so we wouldn't get confused, especially when you're talking about different cultures and different languages. So A group of French chemists got together and they had a method of chemical nomenclature, which means in 1787 they put together a book with prefixes and everything to try to show how to name certain compounds based on their molecular formulas. So this method was very organized, and it was a system of prefixes and suffixes. That's what we're going to talk about, because we're going to identify them, and it gets kind of fun. It's almost like a puzzle, putting these different elements together into compounds, and then naming. You can know by the name how many elements of that or how many atoms of that element are in each one. So the way we do this, we look here. First of all, you need to know this table here. Mono, what's that mean? Mono means 1. Di means 2. Tri, 3. Tetra, 4. Penta, 5. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. That's kind of one we don't use that much, huh? And then deca. So the prefix mono is omitted under certain circumstances. Mono. Sometimes they put mono in the front because it means 1. But when you just put the name of just 1, especially if it's the first compound, you usually don't use mono. So usually the second one you use mono. Okay. So these methods. Let's take an example they have. Let me go on to the next page and we'll look at the example. Okay, you see up here in the top here. So here is NO. Well, we know N means nitrogen, and there's only 1 oxygen, so we say nitrogen monoxide. So nitrogen monoxide. See how they dropped, it's monoxide, but they didn't put 2 O's there when they spelled it, so it's mono, and then they dropped 1 because it didn't look good, really. So it's nitrogen monoxide. This one is nitrogen. There's 2 nitrogens, so we say dinitrogen monoxide. There's only one oxygen. How about this one is nitrogen dioxide, because you have nitrogen. And notice we didn't put mono in front of because it only comes in the second. So nitrogen dioxide. Now, the second, look at here, all of these second letters, what do they end with? IDE. So the second letter always ends with IDE, and the first one doesn't. First element doesn't, but the second one. You always put IDE, that way you know it's a molecule. So here we have sulfur. There's sulfur in the first, and trioxide, always IDE, remember? Then we have carbon, and we have 2 sulfides. So we have carbon disulfide. Two sulfurs is sulfide. Carbon disulfide. Or this is P, which is phosphorus. Phosphorus pentachloride. Chloride. All of these end with IDE. So, and right here it says generally the mono is not used unless there is more than 1 binary compound in the same 2 elements, such as carbon monoxide or carbon dioxide. When prefixes ends in A or O, the element name begins with A or O, and the final vowel of the prefix is dropped. Remember I told you, like carbon monoxide, not carbon monoxide with 2 O's. They dropped the O because looks too weird, I guess, So now you kind of know, those are important to know. And we're going to name some of these, right? Oh, before this here, let's go on to up here a little bit where it's talking about it. Oh, this system is primarily used for molecules or molecular compounds containing 2 nonmetals, which tend to form molecular compounds rather than ionic. They don't use these. This naming is not really used for ions, just for those molecular formulas, right? That's what they're telling you. So, okay, so you have another thing. How about this? On here it says H2O. We know what H2O isn't. It's water, right? But it's known for water, and it's not really known for its scientific name, which would be dihydrogen monoxide. So what is dihydrogen monoxide? It's water, So, but we don't really use dihydrogen monoxide when we're going to get a drink of water, saying, oh, I'm going to go get a drink of dihydrogen monoxide. No, that sounds like poison, doesn't it, when it's just water. So another, okay, let's it says write the formulas for these. So that's what we're going to be doing, writing those formulas. Let me zoom in there a little bit. I hope you can, it was not wiggling too much. So you write the formulas. So we have the first formula, B2BR4, right here. Let's do that one. So what's B? Well, you can look it up on page 19. Remember page 19 I told you. Well, we find out what it is. Well, it says formulas for the comma consist of appropriate symbol for each element followed by the subscript to the prefix. So let's see. Oh, I'm sorry. Let's go. We're talking about A. Write the formulas for sulfur hexafluoride and dinitrogen pentasulfide. Okay, let's do that one first. So sulfur hexafluoride. So first of all, you got to find out what's the formula for sulfur. Well, it's S. We know that. You should have that memorized. And fluoride is F. So hex is 6. So it'd be SF with a 6 on it because there's 6 hex of them. And the next one is pentasulfide. Penta means 5. So, sulfide, so we have dinitrogen pentasulfide. So how many nitrogens? N, 2 nitrogens, and 5 sulfides. So N2S5. So see how I did that? Okay, we're going to go over a bunch more of those. So just you look at it and you just look and see what first of all, I always look to see what the numbers are, and then I look to see, I have to make sure what the element is by looking back to page 19 where we have all those names, those formula names, the abbreviation names, naming them by their formula names. Okay, now let's look at this. B2BR4 and ClO2. So first of all, the name of the first element is unchanged. Remember, you don't put IDE in it. It's preceded by a prefix correspond to the subscript. So here we have B. We find that. What is that? And if we look that up, we're gonna find it's boron. And so there's 2 borons, so I mean diboron. So diboron, and then the next is bromide, or bromine, and we're going to have an IDE. So it's going to be, the name of the second element is to have IDE and the appropriate prefix. So thus we have B2 and B4 is diboron tetrabromide. Tetra meaning 4. 4 bromides and 2 borons. Kind of the B names, huh? Okay, how about this one? So we have Cl is chlorine and oxygen, 2 oxygen. So it's going to be chlorine dioxide, 2 oxygens. So you get that? So, okay. So now we're going to go on to just your problems here, and we're going to do these quickly because these are the kinds you're going to have on the test, and you can just always look them up on page 19 if you don't know the name. So just remember page 19. So let's look at these. So the first one here, so we can have here. So here's how we do this. So let me just give you these. See if you can, if I can put this down so you can see them. Okay. So the first one we have is BO2. So BRO2. So BR, we look it up and it's bromine. And oxygen is O. So now we need to know we only have 1 bromine, so we could say bromine. And then we have 2 oxygen dioxide. Remember, make sure it's in the IED. The next one we have is Cl2O7. So what's ClO27? Well, chlorine and oxygen, right? So there's 2 chlorine, so dichlorine. And then we have 7, which is hepto. So heptoxide. But we take out that extra O, right? So we write down it's heptoxide, right? So that's that one. So let's go on to the next one. Is IC3, right there. IC3, well, iodine, so we have iodine, just plain iodine, and we have 3 chlorines, so trichloride. Remember, it always ends with the IDE. This one here, I had to look this up on page 19. It's selenium. So selenium, and we know that F is fluorine, so we have selenium and 6 fluorines is hexa. Hexa means 6. So selenium hexafluoride. Fluoride. Make sure it ends with IDE. The next one is AS. I had to look up AS, arsenic. And then we have ferrous. So, or actually, I'm not ferrous, but that was Fe. It's fluoride. So we have arsenic, and we have how many fluorides? Tri. So it's arsenic trifluoride. Okay, let's go on to the next one. Nitrogen. Okay, we have nitrogen and oxide. So there's 2 nitrogens and 5 oxygens. So we have dinitrogen pentaoxide. Remember, we'd get rid of that O there. So pentoxide. So it's dinitrogen pentoxide. Okay, the next one here. Iodine and chlorine, right? So iodine, now we don't need to put mono there because it's the first part of it. So we say iodine, and then we say chloride. Always ends in IDE. Okay, the next one. We have oxygen and fluorine. So we have oxygen difluoride. Oxygen difluoride. That's oxygen difluoride. How about this one? ZE. I had to look that one up. Even though we know it's xenon, and then fluorine, or fluorine, which would be how many of them? Tetra. So xenon tetrafluoride. The last one here, Pi3. P would be phosphorus, and that's iodine. So we have phosphorus triiodide. Remember, always ends in IDE. So let's go on to number 2. We're going to do the backwards way here. Okay, so the first one we have to label these. Now they gave us this diboron trioxide. This is actually easier now. Boron we looked up, we know that's B. There's 2 of them, so we put a 2 on the B. Oxide, we know that's oxygen. There's 3 of them, tri. B2O3, so that's good. Okay, now we have carbon diselenide. Okay, I didn't put that down, but basically you can have carbon, you're going to have 1 of those, and you have 2 selenide, which is going to be Se2, right? If you look that up. Okay, tetra sulfur dinitride. Tetra means 4, so sulfur is S, so S4. And di is 2 nitrogen, S4, N2. How about carbon monoxide? Well, we only have 1 carbon, we only have 1 oxygen, so it's just CO, that's carbon monoxide. The next one is disulfur difluoride. So how does this go? We have 2 sulfurs and we have 2 fluorines. So this one here is dibromine monoxide, okay? So we have 2 bromines and 1 oxygen. Mono means 1. Remember, we dropped that extra O there. The next one is dinitrogen. Let's see if we got this here. Dinitrogen tetroxide. Okay, 2 nitrogens, and tetra means 4 oxygen. And the last one is phosphorus trichloride. Phosphorus is P, and then chloride, you get 3 right there. 3 chloride for tri, right? So it's not as hard as you think, right? So I hope those are the answers to those, and now you probably have these on test questions, but that's how the name of molecular compounds. Now we're going to get into the next, we're going to talk about ions.